Math 127 students. Today we're working on section 8.3, which is law of cosines. So along with law of sines, law of cosines is the other formula that allows us to solve oblique triangles. Remember, oblique means triangles that don't have a 90-degree angle, so non-right triangles. So in section 8.2, we had law of sines, which was sine of A over A is equal to sine of B over B is equal to sine of C over C. In order to use this, we needed either A and A, B and B, or C and C. So here are three situations where we use this, and in all three of these, we're given an angle on the opposite side so that we can fully fill in one part of this equation. Remember, this one I have in a box, side-side angle. If you think about it the other way, maybe it helps remember angle side-side. This is the ambiguous case. This is the only scenario where we get possibly 0, 1, or 2 triangles. Any of these other cases, we're guaranteed to get one triangle. These cases, guaranteed to get one triangle, okay? So this is the only one where we might get 0, 1, or 2. So today what we're gonna do is work on law of cosines. This is gonna be for side angle side or side, side, side. So you can see in side, 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 we don't know any of the angles. So we certainly can't use law of sines. If you try to plug in two sides, we'll have two unknowns for the angles. If you do side angle side, same thing. We don't know an angle in its opposite side. So these are the two situations where we're going to use law of cosines. And as I mentioned in section 8.2, you don't need to memorize these lists, but what you should think about if you're given a problem in a future class is law of sines is much simpler than law of cosines. So the first thing I would do is see, can I use law of can I use law of sines? And if so, great, you move forward with the problem. But if you try and set up law of sines and you end up with an equation with two unknowns, that just clues you in to use law of cosines. In general, though, you have to be given an angle and an opposite side, at least one angle and its opposite side. So let's take a look at what law of cosines looks like. Here is law of cosine. So again, we have an oblique triangle, ABC. And you see that there are three different versions of law of cosines. And as you've seen in this class, I like to give the proofs if I think they're instructive and they're simple. And this one is not super simple, so I'm not going to give the proofs of law of cosines. But if you're interested, it's in your textbook. You can also Google proof of law of cosines. So there are three different versions just based on the three different sides. But maybe as you look at this, you recognize that this looks like something similar. So this actually looks a lot like Pythagorean theorem. In fact, when this angle is 90 degrees, cosine of 90 is 0, and this whole part would go away. So Pythagorean theorem is actually a special case of law of cosines. Okay, so what you want to note here is that these letters match, and these letters match. So we have three different versions, and depending on what information we're given off the bat or what angle information we're looking for is which one of these we are going to use. These are listed on your formula sheet for the exam as well. So let's just jump right in. We'll do three examples of using law of cosines. And if you'd like to follow along with me, make sure you have your calculator handy. You will definitely need that. So first one, let's solve the triangle. So the first thing you want to do here, obviously in this section, all of your problems are going to be law of cosine problems, but you want to start thinking about when to use each formula, because on an exam, you're not going to be told which formula to use, and you need to figure that out yourself or in a future class. Okay, so first of all, law of sines is the simplest. So if we tried to set up, for example, sine of B over B is equal to sine of C over C, we'd end up with two unknowns. So no matter how we do this, law of sines isn't going to work. So that means we need to use law of cosines. And as I mentioned, in order to use law of sines, you need to be given an angle on its opposite side. We don't have that here. We have to, with law of cosines, start by finding the third side. And the reason is, if you look at those three different versions of law of cosines, all three of them have all three sides in them. So we must start by finding this third side. So we're going to find B. So since we are given angle B, we need to use the law of cosines version that has angle B in it. And lucky for us, that also has that side B is on the left side there. So we have B squared is equal to A squared plus C squared minus 2AC cosine of B. Next step here, we have B squared is equal to 3 squared plus 5 squared minus 2 times 3 times 5 times cosine of 36. Right, now here you want to be very careful when you type this into your calculator. The first thing is you need to make sure you're in degrees. And then depending on your calculator is whether you're going to be able to enter this all in one step, or you might have to break it up into 2 smaller steps. So every calculator is a little bit different, but go ahead and give this a try all in one step. You should get 9.72949. If you don't get this answer, what you might need to do is enter this part in your calculator and enter this part in your calculator and write them down and then do the subtraction in a separate step. Okay, one of the biggest mistakes I see in this section when I grade paper exams is that you get an answer, you're like, hooray, and you write that down, but students often forget that this is B squared. So we have one more step here. We need to take the square root of both sides. So don't forget to do that. So we get that side B is 3.12. All right, next step, we'll work on finding one of these angles. So I'll find angle A. And then of course, once we have angle A to find C, we just subtract our 2 angles from 180. So because I'm looking for angle A, I need to use the version of law of cosines that has angle A in it. So that is A squared is equal to B squared plus C squared minus 2BC cosine of A. And we are solving for A here. So we'll plug everything in. We have 3 squared is equal to 3.12 squared plus 5 squared minus 2 times 3.12 times 5 times cosine of A. All right, one of the other common mistakes here besides forgetting the square root is students will just dump all of this in the calculator all together. What you need to remember here is that this part is the coefficient on cosine, and this part is the constant that's separate. So you can think about it like if you had 2 minus 3x, we know that this 2 and this 3 are separate. You wouldn't combine the 2 and the 3 together, right? This 3 is the coefficient for the x, it's attached to this x. Likewise, this is attached to the cosine, and you cannot do this all in one step, okay? So you need to keep this constant and this coefficient separated. So in your calculator here, you'll type in this first part. You get 34.7344. Type in this part, we get 31.2, and then cosine of A. Remember, we're solving for A, so we're going to start moving things over to the left. So first step here, I'm going to subtract the 34.7344 from both sides. And students often ask, how many decimal places should you carry? I would suggest 4 or 5. If your calculator gives you a couple more, 4 or 5 should be sufficient to get the correct final answer. So we have negative 25.7344 is equal to negative 31.2 cosine of A. Next step, divide both sides by negative 31.2, negative 31.2. We get that cosine of A is equal to, do this division, we get 0.8248. Now, just as a reminder, every scenario, but that side-side angle, angle side-side, you should always get an answer. So if you get down to this step, and we know cosine has to be between -1 and +1, if you get a number that's outside of that range, make sure you don't put no solution. Make sure you go back and check your work. You should always get an answer for every single problem in this chapter, except for that one side-side angle possibility. The next step here is we'll take inverse cosine of both sides. So in your calculator, make sure you're in degrees and go ahead and hit inverse cosine of 0.8248. You should get 34.4 degrees. Now, lucky for us, oops, I'm missing the last line here. Lucky for us, once we get this answer from our calculator, unlike that law of sines problem, we don't have to ask ourselves, what about our solution in quadrant 2? Why don't we have to worry about that? Well, remember, inverse sine can return a solution in quadrant 1 or quadrant 2. So this is already taken care of for us. Our calculator will tell us the only answer. It might be in quadrant 1, it might be in quadrant 2. We don't have to consider the other quadrant because our calculator can return either of those. The problem with inverse sine was inverse sine can return 1 and 4. So if we had a solution in 2, we had to come up with that ourselves. Okay, so this one, inverse cosine, and you're done. We got 34.4. The last thing we need to do is find the third angle C. We know that the three angles add up to 180, so C is going to be 180 minus 36 minus 34.4, which is 109.6. As we talked about in the other sections, once you get your answers, you should check that your three angles add up to 180. You should check that smallest angle opposite smallest side, middle angle opposite middle side, largest angle opposite largest side, and you should check that the scale of the sides makes sense. So check all of those things. You cannot use Pythagorean theorem because this is not a right triangle. Let's do two more. Next one here, I have angle B is 30, side C is 8, side A is 5. So again, we have to start by finding the third side. We must start by finding the third side. And if you, by mistake, try to start somewhere else, you'll realize really quickly that you need to do this. So the reason why we need to do this is because all three versions of the law of cosines all have all three sides in them. So we need to start by finding B. So since we're given angle B, we're going to use the version that has angle B in it. So B squared is equal to A squared plus C squared minus 2AC cosine of B. Next step, fill in our info. Next step, we can plug this all in our calculator. And again, you might have to do this in two separate steps. If you go from left to right and you don't get the same answer as me, you might do this part and this part separately and then do the subtraction. I get 19.7179677. Next step, don't forget we have B squared, so we need to take the square root of both sides, giving us B is 4.44. Next thing we want to do is find angle A. So to find angle A, we're going to use the version of law of cosines that has angle A in it. So that's A squared is equal to B squared plus C squared minus 2BC cosine of A. And we're solving for A. Okay, so we have 5 squared is equal to 4.44 plus 8 squared minus 2 times 4.44 times 8 times cosine of A. So again, as in the last problem, what you want to be careful, this part is attached to the cosine. So it needs to stay separate from this constant. So in our calculator here, we'll do 4.44 squared plus 8 squared. I get 83.7136. And over here, I'll do negative 2 times 4.44 times 8. That gives me negative 71.04 cosine of A. Next step, we'll subtract this 83.7136 from both sides. So you get negative 58.7136 is equal to negative 71.04 cosine of A. Next step, divide both sides by negative 71.04. We get cosine of A is equal to 0.8265. Next step, take inverse cosine of both sides. So we get A is equal to inverse cosine of 0.8265. Put that in your calculator, make sure you're in degrees. You get 34.3 degrees. Okay, so again, you should get a solution here. So if you have an error somewhere along the line, just check your math. Every single situation here, we should get a solution except for that possible law of sines with the side-side angle. Also here, as I mentioned on the last problem, we don't have to worry about a possible solution in the second quadrant because inverse cosine can return something in quadrant 1 or 2. The last thing we need to do is find C. We know A plus B plus C adds up to 180. So to find C, we take 180, subtract 30, subtract 34.3, and that gives us 115.7 degrees. Once you have your answers, of course, you want to check that smallest angle opposite smallest side, middle angle opposite middle side, largest angle opposite largest side. You want to check up all your angles add up to 180 and that the scale of the sides looks correct. And yeah, that all looks good. So we have one more example in this section, and this is the side. So we won't be given any angles. And this one, I think the last one is probably more useful in your other classes because in the real world, you could easily measure a length with a ruler, but it's much harder to measure angles unless you have special tools. So most of us have a ruler at home or a measuring tape, but most of us don't have something, a protractor or something else to measure these angles. So this one might be the most useful, especially in a solid object. You know, trying to get these angle measurements would be difficult, but you can use law of cosines and figure that all out. Okay, so this is a side triangle. We're given 3 sides. We're not given any angles. Again, in this section, everything is going to be law of cosines. But if you didn't know that and you thought first like, oh, maybe I'll use law of sines, you would set up sine of A over A is equal to sine of B over B. And right away, you're going to get an equation with 2 unknowns. And that just clues you in law of sines is not going to work. In order to use law of sines, you have to have an angle on the opposite side. So first, let's start by finding angle A. Then we'll find B, and then of course, once we have 2 of them, the third one, all we have to do is subtract from 180. So to find A, we use the version of law of cosines that has angle A in it. So that is A squared is equal to B squared plus C squared minus 2BC cosine of A. Then the next step, we'll do the same thing to find angle B. We're going to use the version of law of cosines that has B in it. So that is B squared is equal to A squared plus C squared minus 2AC cosine of B. So we're solving for these angles. So I'll work this one through. If you're a little bit ahead of me, you can start finding B as well. So to solve for A, we'll plug in our sides. So I get 5 squared is equal to 7 squared plus 9 squared minus 2 times 7 times 9 times cosine of A. Again, remember that this part is separate than this part. This part is attached to the cosine, so you need to do these calculations separately. So we get 25 is equal to 130 minus 126 cosine of A. Next step, subtract the 130 from both sides. Get negative 105 is equal to negative 126 cosine of A. Next step, divide both sides by negative 126. I get 0.83333 is equal to cosine of A. We'll take the inverse cosine of both sides. So A is equal to inverse cosine of 0.833333, which is 33.6 degrees. Next up is to find B. We already have this set up. So let's work on finding B. We'll plug in these three sides. So I have 7 squared is equal to 5 squared plus 9 squared minus 2 times 5 times 9 times cosine of B. Again, remember that this part is attached to the cosine and it needs to stay separate. So we have 49 is equal to 106 minus 90 cosine of B. Subtract the 106 from both sides. Next step, divide both sides by negative 90. We get that 0.63333 is equal to cosine of B. Next step, we'll take the inverse cosine of both sides, and we get that B is equal to inverse cosine of 0.63333, which is 50.7 degrees. The last thing we need to do is find angle C. We know that angle A plus angle B plus angle C, these all add up to 180. So to find C, we just do 180 minus the other angles, and that gives us 95.7. Now, a question I sometimes get is, law of sines is so much nicer than law of cosines. So once I get one angle, can't I just use law of sines to get the second angle? And that's actually a complicated question. It does work out if the angle happens to be in the first quadrant, but if the angle happens to be in the second quadrant, then law of sines isn't going to work. You're going to have to do that ambiguous case. So what I would suggest is if you start a problem with law of cosines, you should finish it with law of cosines. So don't go back and forth between law of sines and law of cosines within a problem. So because we use law of cosines here, we use law of cosines here. If you had a problem that started with law of sines, of course you would continue with law of sines because that's much simpler. So in general, if you want to try on your homework, you probably will get it to work out on most cases, but there are going to be some cases where, because that inverse sine only returns an angle in quadrant 1 or quadrant 4, you might have some problems. So if you start with law of cosines, continue with law of cosines on the same problem, that'll make sure you absolutely get your answer correct. So again, on all of these problems, you should get exactly one solution. On all of the problems in 8.1 and 8.2, exactly one solution. The only exception is that angle side angle, right? The one that's a pain in my angle side. That's the only situation where you have to consider 0, 1, or 2 solutions. Every other problem in this chapter, you should get exactly one answer.